Go.
You don't want to see my face, I know. I'll prevent that. It's pretty bad.
Not doing 45. 45 is a dumb question. 45 is a dumb question. Because at the very end of the question they say,
Dumb question.
what is alpha? And at no point in the question do they discuss what alpha is supposed to represent. So in addition to being a very strangely worded and set up problem to begin with,
It's impossible to do.
it's like giving you all kinds of information about a baseball game and then
asking what the
saying,
football score was.
who's the
What is
president of
baseball?
France? They have nothing to do with
I don't
one
know who the
another.
president of France is.
Macron.
Huh. France is a president?
They do.
A lot of countries have presidents that we don't know about.
I probably should know more about how the world works, but I mean, how is that useful information?
I know, we live in America. Like, what is
America,
what is
the only ones here.
What is Europe?
All right, anything besides 45?
What does anyone
That's
outside
it?
ourselves send to
Okay.
ourselves?
Away we go.
It's kind of sad that we don't get educated on that kind of stuff.
I know, right?
Like, everyone knows about America, but America doesn't know anything about
And
it.
everybody speaks English. We don't speak any other language.
Right. We're all racist assholes here. Sorry.
Solve the triangle.
This is 8.2,
This is 8.2, unless
unless
not.
it's 8.2 in disguise.
it's 8.2. We were gonna hit it. That was Friday.
Are all of them
That you did, that nobody had questioned.
Only one of those degrees. The rest are side lines. Side
Oh,
side angle.
okay, yep, nope, I'm
We didn't really do
Good.
anything.
capitals and non-capitals.
So I let people work.
Well, because I think, oh no, I got confused because I write my capital A's like I do like that, and I just it's like, so is the B capital or there's degrees? I confuse myself.
Gee, what?
Okay, ladies, gentlemen, away we go. Talk to me.
Triangle.
What are we given?
Side, side, angle.
Side, side angle? Yes? Everybody agree? Anybody disagree? Draw it. Draw it, please.
We're all gonna draw the sides in different
If
spots.
you're not sure, draw it.
Oh, that might be a side on the side. SAS.
Sometimes I wish it was the other way around.
I need a pencil.
What are we given? SAS? How can you tell that it's SAS as opposed to SSA?
Because the angle, the angle.
The angle is between the two sides. Is that correct?
Yes.
Okay. Can you tell without drawing it
Probably.
that it's SAS as opposed to SSA? How? All three letters are different. If you don't see a repeat, we have an A, a B, and a C. If you don't see a repeat, if you see three different letters up there, then we have SAS as opposed to SSA. If it's SSA, we would have side A, side B, and angle A or B. Yep. We'd have a repeat, that would be SSA. And what does SS, would we prefer SSA or SAS? SAS, why? Because SSA is evil, it's ambiguous, it's ugly, it's more work, it's a pain, whatever you want to say, that's what it is. So SAS, even though we don't know how to do it yet, we know it's got to be better than SSA. Okay? Can we use law of signs here?
No,
Why not?
there's three different.
Because for us to be able to use law of signs, we need to have two of the same. An angle and a side of the same letter. Okay?
It's not a right
Never mind.
So we can't use law of sines. So we need another tool. Now, I believe that you guys have probably heard of this. You probably saw it last year.
Yes.
But we're going to have the law of cosines. I'm stunned, Jake. I'm stunned. You say that. All I know is that I don't like it, he says. Can I show you the law of cosines?
Sure.
That's gonna get some fancy cursive on top.
What? What do you mean it's a lie? Huh?
Was it?
Why is that the Pythagorean theorem?
They updated it.
Okay. But you don't remember there was a
What's-
Pythagorean?
Oh, wait, what's that?
Pythagorean theorem.
That's the Pythagorean theorem.
Mm-hmm. Are we gonna change it?
Can we use the Pythagorean theorem here?
No.
Why not?
It's not a right
It's not a
triangle.
right triangle. It's not a right triangle, it's called an blank triangle. Oblique triangle, good. Just keep using that word as much as we can. It's an oblique triangle. So for an oblique triangle, we need to make an adjustment. And this basically takes care of the fact that it's oblique. Okay? So c squared equals a squared plus b squared.
Minus 2.
Calm. Minus 2ab cosine c.
Yikes.
And that's your adjustment. It's not that hard to remember, which is good because you're going to have to remember it.
Really?
Shocker.
I sounded angry when I said that. I realized this. Really?
You know there's a back to it too. Since it's an oblique triangle, which side is biggest? Whichever one's biggest. We don't know. C, B, A, it makes no difference. So therefore, all of these, any formula like this, we need to be able to adjust to deal with if we're finding C or A or B, but it's the same formula. So if we're to write B squared equals, what do you think we follow it up with? A squared plus C squared minus 2AC cosine of B. Exactly. Basically, this letter and this letter are the same, and everything else are the other two. And so if we're going to do A squared equals 2bc cosine of A. That is the first version of the law of cosines. Well, there doesn't need to be a second version, but I think, as you'll find later in class, I think you'll like the second version to be in existence. So anyway, can you see how this might work out for an SAS type of problem?
Yeah.
Okay, tell me what's right.
Oh.
C squared equals 12 squared plus 7 squared minus 2 times 12 times 7 times cosine 46 degrees. Now on a scale of 1 to 10, the level of difficulty of writing that was approximately
0.
2 if you're stretching it, right? I mean, that was a nothing, correct? Now, here's the nice thing about what we're about to do. Because when we did law of sines, we did some manipulation of the law of sines. We cross-multiplied, we divided if we had to, and then we did whatever we needed to do, and then at the very end we plugged it in the calculator. Yes? Okay. When you have the law of cosines, I strongly suggest, and this coming from the person that always wants you to do things off of the calculator, I strongly suggest that all you do is plug in exactly what is there. So, here's the way I'm going to do this problem.
Is my calculator still dying? Yeah, it is.
Okay? Step 1, on. Woo-hoo, rolling down.
Wow, you turned it on?
Yes.
Wow.
I'm amazed.
That's like level 10
12
hard.
squared plus 7 squared minus 2 times 12 times 7 times the cosine of 46 degrees. Bless you. What did we just find? We found c squared. So c squared is equal to 76.3, or somewhere thereabouts. What do we do now? Square root. So what do I type in? Second square root. Second answer. You do not want to type in 76.3. You want to type in the answer. There we go. That's getting better. Which gives us a C of approximately 8.7. 8.7. Wasn't bad. Can we now, okay, so are we done? No, because we still need to find two angles. Which angles? A and B. Which one should we do first? Does it matter? Okay. Then let's set up law of sines. So, law of sines. Sine of 46 degrees over 8.7. By the way, am I typing 8.7 into my calculator when I do this? No. I really want to use that. Why? Yeah, because we don't want to use rounded numbers. You'll see what happens if anybody types in 8.7. Equals sine of A. Okay. Did anybody want to do B instead of A? Okay, if you want to do B instead of A, do B, please. And if you want to do A instead of B, do A. But let's do that. Set up law of sines, find either angle A or angle B, and work on that and crank that out right now. Go. Huh? Hey, shh. Anybody done? Is anybody done with either A or B? What'd you get?
35.3.
For which one? Okay. Did anybody get A? What'd you get? And A equals 81.2 meters. And we're good?
Okay, wait, I'm lost.
Okay,
Yeah.
Because I typed it in my calculator and I got 0.98.
Okay.
Same.
So did I.
So
Yeah.
that is, wait, no, okay, that, remember, at this point, you're trying to find, at this point, your statement says sine of A equals, what'd you get, 0.98 something,
Yeah.
right? What are we trying to find? Which is an,
Oh, you do inverse
does
sine.
that make sense?
Oh.
Cool. Good, good, good.
I remember that now.
Yay. I know.
Oh, yeah.
Oh, now I get it, yeah.
There's a problem here, isn't there?
It doesn't add up to
So that's the question, right?
I got something different for A. I got 82.8.
Yep. And do you know why you got 82.8? Watch this one. Okay, ready for this? This is great stuff. I love everything that's coming out here. I'm going to explain everything, okay? First of all,
Oof, my calculator did not like
we
that.
got 82.8 as opposed to 81.2. Can I
Oh.
tell you why? Okay. What did you type in here? Did you type in 12 times the sine of 46 degrees divided by 8.7? Okay. Somebody that got 81.2 degrees, what did you type in?
Didn't round
12 times the sine of 46 degrees
over the whole decimal.
divided by second answer. Now, this is perfect because what happened? Okay, Savannah and people in other classes got A equals 82.8 degrees. Now, I have said at a couple of different occasions that if at all possible, we don't want to use rounded numbers. And you all kind of thought, yeah, whatever. How big is a rounded number? Is it significant? 1.6 degrees? Okay? If you are the architect building the house and you use 8.7 instead of the answer, and you get 82.8 degrees instead of 81.2 degrees, what happens to the house?
The building falls over.
It falls down. How is your career going to go from there?
Down.
Yeah, all because
You house.
you used a rounded number. Is that insane? So therefore, okay, we figured, if we use a rounded number instead of 0.2, it'll be 0.3 or something like that. In this case,
It
the
doesn't
rounded
like-
number, in this case, the rounded number is 1.6 degrees. See where I'm coming from there? Okay, we all good on why we don't want to use rounded numbers if at all possible? Good, okay. Thank you for asking that. I'm glad you set that up for me. I appreciate that. Okay, that's issue number one. Issue number two,
Second.
they don't add up to 180 degrees.
Wait, where's the answer then?
Right there. It was that
It's a
one
triangle, isn't it?
that we got at A.
Should the three angles of a triangle add up to 180
After
degrees?
this all day.
So we did something
Then
wrong.
you do the inverse of that.
Oh.
Except that in reality we did nothing wrong. Matt, tell me about that statement. There are two possibilities that can make that statement true. Are there not?
Yes.
Guess what one of those is?
81.
81.2 degrees. There's another one. How do we calculate the other one? Subtract that from 180. Right? Because the quadrants which would make this statement true are quadrants 1 and 2. And so if you typed in sine of 81.2, you'd get 0.98. But if you typed in sine of 98.8 degrees, guess what you'd get? That same 0.98. Okay? So the question becomes, and it's kind of a multiple part question, does it mean we have two answers? No, it doesn't. The only time we will ever have two answers is what? SSA. Only time. Okay? So then question number two becomes, well, if we're only going to have one answer, which one's right? And the answer to that is, I don't know, unless I do everything else first. Okay? So, I have a better idea. Because I
Like
am
shortcuts.
lazy, and I would prefer to not do everything first and then come back and say, okay, so it can either be this or this, so blah, blah, blah. No. So let's make it easy on ourselves. Let's make it easy on ourselves. When we use the law of sines to find an angle, always find the smaller angle first. Okay? If you find the bigger angle first, you don't know. Which one's correct? Without doing anything else, if you had not done angle B, and you strictly went to angle A, how would you know which is correct, 81.2 or 98.8? Answer is, you wouldn't. You'd have no idea. Will 81.2 be the largest angle? If the answer is 81.2, is that the largest angle? Yes. If the answer is 98.8, is that the largest angle? Yes. So there's no way to tell there. Okay? If we do the smallest angles first, and then the last thing we do is the biggest angle, we'll never have to worry about it. We'll always be good. No. Because this is SAS. And SAS will never have two answers. Okay? So, this statement, stay here. This statement is good for both of these angles. It's SAS. We only have one answer. So our angle A is either 81.2 degrees or 98.8 degrees. We don't know what it is. And the only way we can know what it is to get angle B before we get angle A. Therefore, don't do this to get angle A in the first place. Get angle B. Whoop. Whoop. Don't want that. Okay. Get angle B. Add them up. 81.3 degrees. Little.
Not use the 8.
That's 81.3 degrees, right?
Oh, well.
So there's a little rounding issue somewhere in there.
Should be 30.
35.2? Yeah, that makes sense to me. 35.2 degrees, so 81.2 degrees. Ooh, does that sound familiar? 180 minus 81.2 is 98.8 degrees. There's our third angle. I wrote C. I should have written A. And we're done. Yes, sir?
But when you're finding B, don't you have to do the same thing that you did for A?
Good question. The statement for B is true for 35.2 degrees. It's also true for 144.8 degrees. Can angle B be 144.8 degrees? Why not? Two reasons, by the way. What's the first reason? What? C's 46 degrees. We can't have those two angles together. Second reason.
It would make B the biggest side.
It's supposed to be the smallest angle. And if it's going to be the smallest angle, it can't possibly be obtuse. Fair? Good, great questions. Yep.
Okay, so when we were doing this last year, how come we didn't do all this?
You either didn't get problems like this, or he always did the smallest angle first. I'm trying to give you more overall enlightenment.
Because it was not this complicated.
Well, but that's a great point. If you do this, it's not complicated at all. Okay? I made it complicated because I wanted you to see why we want to do that. When I started teaching this class 300 years ago, I remember doing a problem in class early on where we did this. It was like probably the exact same problem, and we did angle A, and we came up with angle A was 81.2 degrees, and then we plugged it in, and we got an angle B of whatever that would have been. Let's see, 81.2, and whatever. And then the back of the book had something different, and the students were all going, well, why? And I'm looking at it, and I'm like, we didn't do anything wrong. We did that wrong. And you're not going to see this in your book. It's not going to be written anywhere in your book. I don't really know why, but it's not. Okay? Jot it down, remember it. When you're finding an angle using the law of sines, always get the smallest angle first. And then you get your biggest angle by adding and subtracting from 180. And you'll never have an issue. Okay? Did that answer all of the weird stuff there? Good. All right. Questions? Here's our next one. The law of tangents. There is no such thing. Just kidding. Anybody still need that? Okay.
So there's a lot of tangents? That sounds...
There is no law of tangents.
Okay.
There's a law of cotangents. It's called
What?
cotangent, but not a law of tangent.
Do we have to learn the law of cotangent? there's a law prohibiting the law of 10 heads. Or at least there should be. It should not be allowed to exist. Ooh, my ears are ringing. That's nice.
Side, side, side.
What do we have here?
SSS.
Side, side, side.
Not what are you given, but what is that?
Side.
A what?
Side, side, side.
Triangle?
Is it a triangle?
I don't think, I don't know.
It's a triangle.
Yes, it's a triangle.
What is that even mean?
Is it a triangle?
It's
Yeah.
a,
Everybody agree?
yeah.
It doesn't say.
Yeah, that's
What is it? Isosceles? What is a triangle or none?
Yeah, it doesn't clarify.
It could be a pyramid.
Could be a what?
It's that one triangle where none of the sides are the same.
Is it a triangle?
Yes.
Why is this
Well, we don't,
It has 3 sides. It could be any 3
Oh,
sides.
wait, you don't have
prism.
any.
we don't know because we don't know the angles.
What if I told you we didn't need to know the angles?
Because
There is no what if on this problem. You're clearly understanding where I'm coming from here. So go deeper and figure out why I'm asking what I'm asking. Why? If you say it's not a triangle, why?
Well,
You have to go back into the dark recesses of last year.
Oh, Lord.
There's what?
oh,
No way to prove it.
no, we can't prove it.
well,
We don't want to. We don't want to prove it. That's,
Draw it. Draw it to scale.
Who has a ruler?
I don't think I have enough room for that, sir.
Oh, wait. Is it just Pythagorean?
What do you mean it's not?
what?
I don't get my work.
13.
Yeah, it could be a triangle. I don't know how.
We were meant to take you seriously, yes, by trying to draw it to scale.
Well, I mean, obviously it's hard to draw to scale, but try to draw it to scale.
Oh, I say
It's gonna be
Well, see, I have this wonderful thing called notebook with boxes.
I know, with the graphing paper.
At some moment, somebody's going to go, oh, there it is.
Okay.
There it is. I knew it was coming.
Arjun said no.
Go.
So, the two sides together, they add up. It's not long enough to.
That's what I was just saying that.
Wait, what?
Oh.
I knew it was coming.
It is.
Okay, explain
You're
that
not long
again so that everybody, so it comes back in everybody's head.
So the longest side, it's not, there's no possibility to connect the other two sides to make it as long as the other side.
So what's the triangle rule that I'm getting at here?
The side has to be
The two legs have to
bigger
add
than
up.
the other two combined.
Say that again?
So side C has to be bigger, wait no. Smaller than the other two.
Two sides have to add up.
Well, not at.
Yeah.
Well, the other.
Well, yeah, you just flip-flop what you guys were saying. You guys said the same thing. The sum of any two sides, the lengths of any two sides of a triangle, must be greater than the third side. Has to be. If you try to draw this to scale, if you say that this is 4 miles, and this is 7 miles, and then, let's see, that's 7, so that would be 7, and then another 7, put us out to about there. And there's our triangle. Last I checked, that's not a good one. You know what I'm saying? Does everybody remember that rule?
Yeah.
Okay. Just trying to remind you of some of the things that you learned a year ago. Okay?
Yeah.
You learned this. You learned it. You may not remember it, but you do once we start to talk about it, at least a little bit.
Well, I mean,
You said it.
I believe it now.
And if you use logic, you certainly can see it. If you draw it to scale, you see, I mean, you'd have 4 miles, 7 miles, and then 13 miles. Even if they're end to end, they don't reach the third one. let alone if there's any type of angle. So, this doesn't work. What can we change it to? 10.
Yeah.
Okay. Now what are we given?
Side, side, side.
Side, side, side. Is this a triangle?
Yes.
Yes, it is. Now it's a triangle. Okay there? Questions on that part of the discussion? Okay. SSS. How does that work for law of sines? How does it work for law of sines? Not very well, because no angles, which means that we can't have two with the same letter. We don't have a side and an angle of the same letter because we don't have any angles in the first place. So therefore, this has to be a law of cosines problem, which kind of looks pretty ugly, doesn't it?
Yes.
So we have two options. Option number one is plug the numbers in and then do the algebra to make it work.
No, thank you.
Option number two is do the algebra first and then plug the numbers in from there.
Thank you.
I suggest that we do option two. And here's the other thing. Once we do the algebra, it kind of gives us a new formula. Remember a few minutes ago I said this is version 1?
Yeah.
Okay, well, we'll come up with version 2, and now you'll have it also as a formula that you can use. All right? So here it is. Cosine of C is equal to a squared plus b squared minus c squared over 2ab.
Yeah.
Which I feel pretty confident that you guys could get there algebraically. Well, we'd subtract the a squared, we'd subtract the b squared, and then we'd divide by negative 2ab. When we divide by the negative, we can basically change all of the signs in the problem, and that's all we did. So usually you would have had c squared minus a squared minus b squared over negative 2ab. That's just too many negative signs, so we just change the signs of everything. We got that. Let's say if we instead wanted to find the cosine of b, what do you think?
A squared, b
A
squared.
squared plus c squared minus b squared over,
2ac.
yep. And finally, if we were doing cosine of a, it would be
A squared.
okay. And now you have the two different versions of the law of cosines. You have each one in 3 different ways. So you can pick out whatever you need to pick out. Now, as we get started on this problem, I have a suggestion. And this time, that's all it is a suggestion. This was a very, I won't call it a rule, but certainly you could call it a rule. This is a suggestion. If you're using the law of cosines to find an angle, like we're about to, find the largest angle first. If we find the largest angle first, then we don't have to worry about